Okay, so if we're solving using the quadratic formula, first we need to get one side equal to 0. So make sure your equation is in this form. Ax squared plus bx plus c equals 0. And then in order to use the quadratic formula, we need to know a, b, and c. A, b, and c are numbers. A is the coefficient of x squared, b is the coefficient of x, and then c is the constant. Once we know our numbers, we plug them into the quadratic formula. I'm sure once we write this down, it'll look familiar, so make sure you write this down. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so write down the quadratic formula. Make sure you have that in your notes and make sure you write it down correctly so that we can use it for our examples. Hopefully you already know it from Algebra 1 and Algebra 2. So hopefully this looks familiar. All right, so we're going to do 2 examples. We are going to solve each equation using the quadratic formula. Write all irrational and complex answers in simplest form. So if we can simplify our radicals, we want to. All right, so please write down number 15. Example 15. We have negative k squared minus 8 equals 10. Equals 10k, I mean. Negative k squared minus 8 equals 10k. Okay. So when we're using the quadratic formula, we do need to get one side equal to 0 to start with. It doesn't matter which side is equal to 0. But usually, if I have a quadratic equation, I don't like to have my leading term have a negative. So see how this has a negative k squared? Since we're going to use the quadratic formula, it doesn't really matter, but I would usually try to factor first. So I'm going to get the left side equal to 0 in this case. So that way I have a positive k squared. So to get rid of the negative k squared, I'm going to add k squared to both sides. And to get rid of the minus 8, I'm going to add 8 to both sides. So then the left side is equal to 0. Now, on the right side, you could write it in this order, 10k plus k squared plus 8. But usually to make sure we have the correct a, b, and c, I want to write it in this order where the x squared, or in this case, the k squared comes first. So I'm going to write this as k squared plus 10k plus 8. Now, if we would have moved the 10k to the other side and got a 0 on the left, we'll still get the same answer in the end. Okay, so it doesn't matter which side you get equal to 0. All right, so now I need to figure out what my a, b, and c are. A is the coefficient of k squared, so the number in front of k squared. If there's not a number there, it's like an a, or it's like a 1. So in this case, a is 1, b is 10, and c is 8. They're all positive in this case. They're all plus, so they're all positive. All right, so let's look at what that looks like when we plug it in. X equals, so I'm just plugging it into this formula, negative b, so that'd be negative 10, plus or minus the square root of 10 squared minus 4ac. So that'd be minus 4 times 1 times 8 all over 2a. So all over 2 times 1. All right, so that's what it looks like when we plug everything in. Notice we're just plugging in the numbers. So in this equation, everything that's in blue is just part of the equation. I plugged in the B in this place in purple. I plugged in the A in 2 places and then the C. All right, then all we have to do is simplify. So I like to simplify what's under the radical first because the radical acts like a grouping symbol, so I want to simplify that. Notice when I plug in all my numbers, I plug them in parentheses, which is a good habit, especially if we have negatives. Here we only had positives, but it's still a good habit to use parentheses. So right here, 10 squared is 100. So this is the part inside the radical, minus 4 times 1 times 8. 4 times 1 is 4, times 8 is 32. Okay, so under the radical, 100 minus 32 would be a 68 under the radical. Okay, so now I'm going to rewrite this. I simplified the radical part. So x equals negative 10, since we had negative b, plus or minus square root of 68 over 2. Okay, so what I've done so far is I've just simplified the equation after I plugged in the numbers. Now, I'm not done yet. If you got to this part, that's good, and that shows that you're proficient. But to be highly proficient, we should also be able to simplify. To simplify, remember a fraction bar means divide. A common error, though, is to try to divide this 68 by this 2. I cannot divide those because the 68 is under a radical. So what I have to do first is we have to simplify this radical. All right, so let's simplify square root of 68. I have it written here. I'm going to break it down. Remember, when we're simplifying radicals, we break it down into prime factors and look for pairs. So 68 can be 2 times 34. And 34 can break down more to 2 times 17. So I have a pair of 2's and then a 17 left over. Or that's 2 squared times 17. But because it's under the radical, remember anything that's a pair simplifies. So the square root of 2 squared is just a 2. And then we have the 17 left on the inside. All right, so that's what the radical part simplifies to. So now we have x equals negative 10 plus or minus 2 square root of 17 all over 2. All right, so I took this radical, the square root of 68, and I simplified it to 2 square root of 17. Now that we simplified, now I can do the division. In this case, both of these terms in the numerator can divide by 2, so make sure you divide both of them. All right, so here's what our final answer looks like. Right here, I have to divide the 10, negative 10 divided by 2, so that'd be negative 5, plus or minus. I also have to do 2 square root of 17 divided by 2. The 2's divide out to give us a 1 square root of 17. You don't really have to write the 1 though. So we would write our answer as negative 5 plus or minus square root of 17. Okay. So to be proficient, we should be able to get to this step right here. To be highly proficient, we should be able to simplify our radical and then reduce or divide like we did here. All right, so that's what the quadratic formula looks like. I bet that looks familiar to everybody. Let's do another one. So let's write down 16 in our notes. All right, so write down 16. X squared, or sorry, 6x squared equals 3x minus 9. 6x squared equals 3x minus 9. All right, we're going to solve this with the quadratic formula as well. Again, it doesn't really matter which side you get equal to 0. And especially when we're doing quadratic formula, it doesn't matter. However, I usually like to keep my leading coefficient positive. So see how this one has a 6x squared, it's already positive. So I actually want to go ahead and keep that where it is. I'm going to get the right side equal to 0 in this case. So I'm going to subtract 3x from both sides. Subtract 3x, and then I'm also going to add 9 to both sides. So then on the left side, when I write it in order, I would have 6x squared minus 3x plus 9 equals 0. If we would have done it the other way around, we would just have 0 equals negative 6x squared plus 3x minus 9. But in the end, you end up with the same answer. So it doesn't matter which side is equal to 0. All right, so then we can figure out what our numbers are. A is 1. Right here, B is negative 3. So be careful right there with your signs. And then C is 9. All right, so let's plug those in. All right, so when I plug those into the quadratic formula, oh, yeah, guys. People are responding in the chat. Yeah, A is not 1. A is 6. Okay, my bad. It's the afternoon and I'm tired, as I'm sure some of you are too. So those of you who responded in the chat, thank you, because yeah, A is definitely 6, not 1. Okay, so we have A equals 6, B equals negative 3, C equals 9. All right, so then let's plug it into the quadratic formula. X equals negative B. So this time when I plug it in, I'm going to have a negative 3. I'll simplify that in a minute. Plus or minus the square root of negative 3 squared minus 4 times A, which is 6, times C, which is 9, all over 2A. Okay, so that's what it looks like when we plug everything in. So we have negative 3 plus or minus the square root of negative 3 squared minus 4 times 6 times 9 all over 2 times 6. One thing I want you to notice here is, especially when we had a negative number like the negative 3, I did plug it in parentheses so I can make sure I get the correct signs as I'm solving this. All right, I like to simplify the radical part first because the radical is a grouping symbol. Now be careful right here. I did write it in parentheses because this means negative 3 squared, or negative 3 times negative 3, which is positive 9. If you're using a calculator, some calculators are really picky and you do have to put that in parentheses if you're doing that on a calculator. So just be careful of that. So this should be positive 9 minus, right here, 4 times 6 times 9. I don't know what that is offhand, so rather than try to figure it out, I'm just gonna put it in my calculator. 4 times 6 times 9 is 216. And then 9 minus 216 is negative 207. So under the radical, we would have a negative 207. All right, so let's simplify what we have so far. X equals, right here, since I had a negative 3, rather than writing that, that would just become a positive 3. So we have 3 plus or minus square root of negative 207 over 12. Okay, so again, if you got this far, that is proficient, and it means you can use the quadratic formula, but we should also be able to simplify. In this case, our radical can definitely simplify, so I'm going to simplify this. At the very least, hopefully you notice it has a negative on the outside. So a negative on the outside, we have to simplify it to an I. A negative under a radical is imaginary. So this would become I square root of 207. Let's see if 207 does. I think it's divisible by 3. I'm going to use my calculator to check so that I don't have to divide in my head. Yeah, 207 is divided by 3. So 207 can break down to 3 times 69. And then I think 69 is also divisible by 3. So 69 can break down to 3 and 23. All right, so then I have a pair of 3s and a 23 left over, which means when I simplify this, the 3 from the pair is going to go on the outside along with the I. So this is going to simplify to 3i square root of 23. So this radical square root of negative 207 can be replaced with this 3i square root of 23. Right, so I'm going to write what I have so far. 3 plus or minus 3i square root of 207. Oh, that's kidding. Not 207 anymore. 3i square root of 23 over 12. Okay. Now, this can actually reduce more. So let's talk about how we would write our final answer. There's 2 ways we could do it. One way you can do it is if you want to leave it as one fraction, so with the whole thing over a number, we can reduce. In this case, the 3 and the 12 doesn't divide evenly, but it can reduce. In this case, all the numbers outside the radical, 3, 3, and 12, can be reduced by using a common factor of 3. They all have a 3 in common. So one thing we could do is we could divide all of these by 3 to reduce. Notice I wouldn't do anything with the radical because the 23 is under the radical. So I can't do anything with that. All right, so if I divide here, 3 divided by 3 is 1, plus or minus. Here, the 3 divided by 3 would give us a 1 as well. So we'd have 1i square root of 23. We don't really need to write the 1 in front of the I. And then on the bottom, we would have 12 divided by 3, which is 4. Okay, so this is one way we can see the answer. So notice here, I reduced the 3, this 3, this 3, and this 12. Okay, the other way we can write our answer, some people prefer this way, rather than writing one big fraction, I could divide each part by a 4. So I could put a 1 over 4 plus or minus I square root of 23 over 4. So that's another way you could write it as well. So the difference here is just each part is over a 4 instead of the whole thing over a 4. All right, so that is what the quadratic formula looks like. Most students don't usually have too much trouble plugging in the numbers, but sometimes we struggle with the simplifying a little bit. Hopefully the review that we did in R1 and then also 1B helps, but hopefully we are able to simplify. Okay, there is going to be one more type of problem in our notes, but first, before we do the last example in our notes, I want to do some practice with quadratic formula. All right, so make sure that you have the quadratic formula written down somewhere. And we're gonna do a couple practice problems. All right, so with the practice problems, you can do them on whatever, they don't have to be in your notes. If you want them in your notebook, that's fine, or you can just put them on any scratch paper or even your whiteboard if you got one of those so far. All right, so here's our first practice problem. All right, this one, solve using quadratic formula. The equation is 2x squared plus 3x minus 6 equals 0. So pay attention to what numbers are A, B, and C. And be careful with the signs. And okay, let's take like a minute or two and solve this. If you think you have your answers, you can type them in the chat. So our last example, we're going to talk about projectile motion. So this is just talking about the motion of a projectile or something that is shot or thrown into the air. Obviously, if something's shot or thrown into the air, it's eventually going to come back down. So in this example, first we're going to read it. You don't have to write down necessarily every word, but let's read it and then we'll write down some of it so you have enough of the problem in your notes to reference it later. All right, so number 17 says a rocket is launched upward with an initial speed of 325 meters per second. Its path is modeled by this equation. Okay, so we get the equation h equals negative 16t squared plus 325t, where h is the height of the rocket and t is the time in seconds since it launched. And the question we're trying to answer is, when does the rocket reach the ground? Okay, so let's write down parts of this. So we know we're talking about a rocket. So a rocket's path, we don't really need to write down this first sentence. The 325 is already get part of our formula here. So let's write down this. A rocket's path is modeled by the equation. So make sure you write down the equation. A rocket's path is modeled by the equation h equals negative 16t squared plus 325t, where h is the height. So you could just make a note of that as well. H equals height of the rocket and t equals time. T is the time in seconds since it launched. Okay. A rocket's path is modeled by the equation h equals negative 16t squared plus 325t. H is height, t is time. And the question we're trying to answer is, when does the rocket reach the ground? When does the rocket reach the ground? Okay, so if we think about what's happening here, the rocket is launched upward, so it's going up, and then eventually it's going to come back down. So we want to know when the rocket hits the ground. So let's say that this is the ground here. When we first launched the rocket, this point would represent when we're starting. When we first launched the rocket, that would be when t is 0 and h is 0. The time is 0 because we're just launching it, and the height is also 0. What we're trying to figure out is here, when the rocket hits the ground. We don't know the time. That's actually what we're trying to figure out. We're trying to figure out, when does the rocket reach the ground? But when the rocket reaches the ground, we do know the height. It's back to the ground again, so the height is 0 again. Okay, so we're trying to figure out the time or how long it takes for the rocket to reach the ground. So since we're trying to find when, we're trying to find when t, we don't know what t is, so t is our question mark or what we're trying to find, and we do know the height is 0. H equals 0 when this reaches the ground. So here's what we're going to do to solve this equation. We're given this equation here. We're going to plug in 0 for h. So plug in h equals 0, and then we'll be able to solve for t. Because t will be, that's the variable we're trying to find. Okay, so plug in h equals 0. So in this equation, I'm plugging in 0 for h. So we have 0 equals negative 16t squared plus 325t. So we're going to plug in 0 for h, and then we're going to solve for t. So if you look at this equation here, 0 equals negative 16t squared plus 325t. Because it has the t squared, I know this is a quadratic equation. When we have a quadratic equation, we have 4 different methods to choose from. And in this case, we're not told to pick any specific method, so we can pick any method we want. The method I usually try first is I try to factor. And then if I can't factor, then I use the quadratic formula. So those are the 2 I use the most often. So this is, like we said, a quadratic equation. Make sure it's equal to 0 first, which it already is. And then I can solve this. The method I'm going to try is factoring. This one actually can factor. The only thing I can factor, though, since it's not a trinomial, I can factor out a GCF, a greatest common factor. The GCF in this case is just t. T is the only thing those terms have in common. All right, so let's factor out the t. So remember, when we factor out a GCF, that factor, that t is going to go in the front. So I'm going to have the t in the front. And then in the parentheses is what I would have when I divide. Right here, one of the t's would divide out. So I'd be left with negative 16t. And right here, the t's would divide out. So I'd be left with plus 325. And it's still equal to 0. All right, so this is what we have after we factor out a t. T times negative 16t plus 325. Okay. Then remember, after we factor, we solve by setting each factor equal to 0. So I have to set the t equal to 0, and I have to set the negative 16t plus 325 equal to 0. Okay, so set each factor equal to 0 and then solve. This equation is technically already solved for us. T equals 0. That's one of our solutions when the rocket's on the ground, but that's actually referring to our starting point here. Okay, so I still need to solve this equation. Now that this is a linear equation, I can just isolate the t. So if I'm trying to solve for t here, I would have to subtract 325. So then I'd have negative 16t equals negative 325. And then divide by negative 16. So then the t here would be by itself. On our signs, I have a negative 325 over a negative 16. Since I have a negative divided by a negative, I'm going to write it as a positive. So I have positive 325 over 16. And remember, t is talking about seconds. Okay. So we solved for t. Now, remember, I normally tell you to leave your answers as a fraction because they're more exact. But in this case, usually in word problems, it would make more sense to approximate. Because if I told you, okay, the rocket hits the ground after 325/16 seconds, you probably still wouldn't know how many seconds that is. So this is a case where it makes more sense to approximate our answer. So I'm going to divide this on my calculator. 325 divided by 16. Notice it gives us 20.3125. If you want, you can write all of it, or we can approximate. If you approximate, oftentimes we use a squiggly equal sign to show that we're approximating. I'm just going to say approximately 20.3 seconds. So this is what I'm going to say for my answer. Notice this is going to be our time. This is going to correspond to the time when the rocket hits the ground. All right, so T, that's the time, is approximately 20.3 seconds. All right, so in this problem, the equation we had, we weren't told which method to use, so I chose factoring. If you wanted to use quadratic formula, you could. Our C value would just be a 0. So you could use quadratic formula, you could use factoring. Square roots wouldn't work in this case, and completing the square you could use, but man, your fractions would be all crazy. So I would never want to use completing the square. So the two methods I usually try, if I'm not told what method to use, I always try factoring first, and then quadratic formula if I can't factor. All right. So like I said, that's our last problem of both the day and this whole section as well.